Welcome, Calculus BC. This is 9.5 Vector Calculus. Let's begin. Final lesson right here. There's a warm-up to do. Hopefully you're doing it the sub, and if you have homework questions, that's great. But let's talk about vector calculus. When I'm talking vector calculus here, we're looking at if you got if you know anything about vectors, it's not points anymore. It's kind of like I have a point out here, but it doesn't represent a point. It represents this vector, which is kind of a line with the direction. It has magnitude and direction going out to here. So this is more of a physics-y thing. It's talking about motion. The stuff we do with vectors is very similar to parametric equations, but we just kind of write it in vector format. Your position vector will just be the functions x of t, comma, y of t. Notice here I do these angled brackets here. That's typical for vectors. Velocity will be derivative, just like it is in normal cases, so it'll be x prime of t and y prime of t. Acceleration vector, as its acceleration is the second derivative, so it'll be the second derivative of t and the second derivative of y. So position, velocity, acceleration. And here's where it gets weird, different, a little bit different. This is what you'll have to know. What is the speed vector? So the speed vector, speed is usually the absolute value of velocity. Well, in the case of vector calculus right here with parametric equations, we do the magnitude of velocity like this, and usually use these double lines to indicate magnitude. Sometimes they're just very bold lines, but we'll just stick to this. And this is going to be the square root of x prime squared plus y prime squared. So very similar to what maybe you think for like the arc length formula. In fact, distance traveled is the arc length. So it's like, hey, if we have a parametric equation kind of going on this, like how do I travel on it? It's going to be from A to B, if I'm traveling from A to B, of the square root of x prime squared plus y prime squared. So distance traveled is the arc length basically. Speed is this kind of magnitude. Speed should actually be just it's kind of like, I don't know, it's the absolute value of the velocity. So think distance formula. At rest. So when we're at rest here, usually at rest means our velocity is 0, but it's the velocity of both components, the x and the y component must be 0. If it was only x being 0, the y would move up and down. So both have to be 0 to be at rest. And you'll see how that is used. So for example, I given this position vector, we're going to do a few different things right here. Number one, I might want to graph this. Now, you can graph it with a calculator. If you do, it's going to look like something like this. So graph your parametric equations. Velocity vector, so you have to find the velocity vector time equals 0, so v of t is going to be the derivative of those terms. It'll be 6t, comma, 3t squared minus 6t. And then, so v at 1, 6 times, this will be 3 minus 6, so that'll be negative 3. So 6, negative 3 is my velocity at time 1. Now if I want to find the acceleration vector, I'm going to derive velocity. It's going to be 6, comma, 6t minus 6. And your acceleration at time equals 2 is going to be 6, but it doesn't change that one. And it'll be 6 times 2 is 12 minus 6 will also be 6. That's your acceleration. So you derive these, plug it in. All right? Moving on to the next thing. What if I want to find the speed? Okay, again, the speed, I've already forgotten this, is the square root of x prime squared, y prime squared. Okay. So, the cool thing is I already did this in part B, so it's 6 and negative 3. So I'm going to take those answers and say it's the square root of 6 squared plus negative 3 squared. Again, I did those in part, whatever that was, B. No, that was F. That's really weird. I'm out of order. So what's that going to be? Square root of 36 plus 9, so it's the square root of 45. We can just leave it like that. You don't have to simplify. Now speed again. Oh, had the formula right there. Hey.
Come on, Scott Kingery.
All right, the distance traveled. So this is using this formula, and this is the arc length that we kind of learned about last week. So from t equals 0 to 3, it'd be the square root from 0 to 3 of the square root of x prime squared. What was x prime? So it'd be 6t, and then, so it'd be 6t squared plus the other thing, which was 3t squared minus 6t squared. 3t squared minus 6t squared dt. Now, are you doing that by hand? Nope. We don't do that one by hand. We're going to do it with a calculator, so I'm going to pull this up. You can see it on my screen. as we are doing this, does it show up? Oh. I wish it would. Hello. Oh, you're back. Welcome. Yeah, how was the testing?
So I guessed on all the ones I didn't know.
That's, oh man.
Don't worry. It was only a lot of them that I didn't know.
Oh.
Yeah.
All right, folks. I'm going to get a window capture on here because I really want to. I really want you to see my TI. Oh, sweet. I figured it out. Awesome. So you can see my calculator now. I'm going to turn the other thing off. I'm recording live, Gabe, so you can watch this tomorrow with the sub.
Oh, cool. All right.
So we're going to go square root, or we can go to integral. Can make this a little bigger right here. And go, I'm going to go square root of 6t squared. I'm going to be lazy, just say 36.
A little bit.
T squared, a little bit lazy. A lot of bit lazy. That's true. Randy called me out. He's not wrong, folks. Minus 6t. And all this is squared. And you got to close off the square root, and I go comma t, comma 0, comma 3. So yours might be different. That's fine. I hit the enter button. It's going to give me an answer. Hopefully. It's probably going to take a long time. And it did the work right here. Does that look correct to me? Probably. So my answer would be 28.583. So 28.583 is my distance. If I had units, I'd put it down, but I don't have units. Or do I have units? Nope, no units. All right, the times when the particle is at rest. Okay, so this is trippy. Well, let's move this calculator, right? So, particle at rest is when the velocity is 0, 0. So the x and the y velocity. Let's go back to our velocity functions right here. It was 6, so again, velocity function 6t, and then it is, 3t squared minus 6t. So it's when both components are at rest. So I'm going to do the x component first. So 6t equals 0 will happen when t is 0. Okay, so time is 0, but that's not the final answer. I have to make sure it's when y. So y is going to be 3t squared minus 6t equals 0. Factor out a 3t. It's going to be t minus 2 equals 0. And so this happens at t equals 0 and t equals positive 2. So my final answer is where it exists on both of these. So it's only at t equals 0. T equals 2 doesn't exist because there's no 2 over here. Okay, moving on. Oh, okay, so hey, you can integrate, you have acceleration, and some maybe I want to go backwards and find velocity. So this is how I do this. Velocity, well, we got to integrate both sides here. So I'm going to integrate for the x component of velocity and the y component of velocity. And then you're going to use the initial conditions here to figure out plus c. So my v of t is going to be just the integral of each of these, the antiderivative. So I'm going to write it like this way with plus c's first. So it'll be integral of negative 2 cosine of t squared is going to be negative 2 sine of t squared times c plus c. And then this is going to be positive 3 cosine of t plus c. Now for each of those, I got to figure out the plus c. If you know at v of 0, so when t equals 0, x is 0, and that's 3. So I can say for on the x side 0, from this 0 equals negative 2 times sine of this 0 plus c, sine of 0 is 0, so 0 plus c equals 0, so c equals 0. Okay? Over here, I'm going to get 3 from that 3 is equal to 3 times cosine of 0 from this 0 plus c. So 3 equals 3 times 1 plus c, so 3 plus c. C also equals 0. That's nice of them. So my velocity function is going to be negative 2 sine of t, comma 3 cosine of t. And then you're plugging in pi over 4. So at pi over 4 right here, I'm just going to do the work right here so I can erase it. Your velocity vector is going to be negative 2 sine of pi over 4, comma 3 times cosine of pi over 4. Do I simplify that? Nope, I'm too lazy. Position vector, so I'm going to have to integrate this thing. So position vector, I'm going to say, what's our S of t, sometimes our notation? So antiderivative of this one is going to be positive 2 cosine of t, comma 3 sine of t. Okay, and also plus c's. So we have to solve for c. We notice that s of 0 is this thingy right here. So I can say 2, for the x values, 2 equals 2 times cosine of 0 plus c. So 2 times 2 equals 2 plus c, so c equals 0. That's easy over here. And on the other side, we'll move this picture out of the way. We're going to say square root of 2 over 2 equals 3 times sine of 0 plus c. Sine of 0 is 0, so c equals square root of 2 over 2. Okay, so my position vector s of t, sorry you couldn't see that. Oops. There you go. Is going to be 2 cosine of t, comma 3 sine of t plus square root of 2 over 2. And then we're plugging in pi over 4. If we plug in pi over 4, so s of pi over 4 is going to be 2 times pi cosine of pi over 4, comma 3 sine of pi over 4, plus square root of 2 over 2. And there's an answer. Ugh. It's hard to write stuff. So,
How do you pop fly a bunt?
how do you do that? No one knows.
Bro, I hate this game.
Oh, speed.
Huh? Look, I
Wait,
bunted the ball.
speed when time when the particle's at rest. There's a lot of other things to do. Hopefully you got enough of this. Your assignment will be something on Khan Academy, folks. If you want more of these, figure it out. Direction of the particle sometimes happens. Don't worry about that function if that pops up. Don't remember what it is. Ignore these. Here's some extra examples. Oh, here's some classwork. Should you do this? I'm probably just going to assign some Khan Academy. Look at the classroom, folks. Thank you. See ya later.